Hi, this is Claude Junkins, and this is going to be a review of our class that we had on Monday for CET 120 Technical Drawing, first class of the semester. Some people, for one reason or another, weren't able to make it. This is also going to be available for those that would like to review classes, go through some different exercises. As graphic communications or technical drawing this semester, we are going to be primarily sending information through electronic format. You'll be dumping homework into folders on first class. You should see a folder in your first class desktop called CET 120. If you don't, send me a first class email and I'll make sure you get on there. Some people hadn't had their first class set up yet, so we need to make sure that you're in the system so that you can pick up the information. There is also a copy of the syllabus in that folder on the first class CET 120. Let's start out talking about introduction to graphic communications. I got a little PowerPoint here, and we'll take a look at this. And just as kind of an introduction, since the early times we've looked at graphic communications as a way to communicate to other people. Well before the written word, we had pictures on cave walls that indicated information about hunting and fishing and whatever life around the caves involved. Sometimes we stretched our information a little bit, made our horses a little fatter or whatnot, and that was great. But as we get into technical communication, we're going to look back at some things we learned in junior high. One being the old number lines that we probably thought we'd never use. We use these to graph images, but in two-dimensional technical drawing, everything has an XY coordinate. There are points in space in a 2D format that we can extend things to what we call a plane of projection. We consider this a glass box in 3D. In 2D it's just a plane, but each plane has its side. In 2D you have a front view, or it could be a side view, it could be a top view, but it only has the two axes. If we were to take this image of the head, for instance, and outline some of the prominent areas, some of the visible edges of this face, we can extend those out, and each of these faces, each of these edges would have a numerical XY coordinate. We remove the image from the background and we're left with a drawing on this plane of projection. If we turn the view sideways, we have another plane now, and we have what's called a Z-axis, the third dimension for depth. In other words, we're looking at the side of this face now, and if we again trace those lines and extend those lines to the plane of projection, that flat sheet, we end up with a profile of this face. If we put it all together, we end up with a XYZ coordinate system, whereas this third three-dimensional space within this imaginary glass box, everything has an X, Y, and a Z coordinate to provide both two-dimensional location and a depth within that space. A glass box has 6 sides. It has a top, a front, a right side, a left side, a back, and a bottom. If we were to put that same face within this box, we can extend these images to this plane of projection in an orderly fashion so that things can be unfolded and realized, and this is referred to as an orthographic projection. If we look at this in a 3D mode, we'll give it a second to warm up here, but you can see now as we rotate this around, we can visualize those XYZ coordinates from the plane of projection. We can imagine this face within here by looking at these 2D planes. Let's boot out of this for a second. We'll close this down. And we're going to talk about, you have a book called Microstation V8 workbook. You also have a sketchbook. Let's go through the first chapter of this textbook and talk about some of the basic elements of file management within our computer CAD system. Almost all of the drawing we do this semester is going to be done on the computer. We're going to be working with a program called Microstation V8i. It's a little newer version than what this book explains, but the tools are the same. And if we look at chapter 1, and I think you can be able to see this okay, it talks about input devices, creating files, and the screen layout. I've been working with this software for 10 or 12 years now. Become fairly proficient. You should probably know that I do work in the Office of Facilities Management on campus as a project manager and director of engineering support services. So I use this software every day. It becomes more and more evident that things can be done more efficiently on the computer. Not necessarily from just the drawing. Yeah, we can sketch things out rather quickly with a pencil and a paper, but there are other attributes to this system that also need to be included. Layers, being able to use multiple layers within a drawing to be able to turn things on and off to provide different aspects of a model of a project, whether it's architectural, mechanical, doesn't really matter, but they all kind of have their own place, and it just saves having to, when we were doing drafting on the board, if you wanted to do, for instance, a plumbing plan on a architectural floor plan, you had to run a sepia print and then draw on top of that sepia print, print it out. If the floor plan changed, it messed everything up, and with the electronic versions, if we make a change to the floor plan, it's immediately evident in the electrical plan and the plumbing plan and all of the other drawings that there's been a change there, because we're using one basic element to provide the drawings for all of those. Microstation, and we'll be working with this. There is a website listed on the syllabus that tells you where to go to download the software. The software has two portions. One is a prerequisite, the PBDA, whatever it is, .exe is the prerequisite program. You need to run that first. Then you're going to run the Microstation program, the MS whatever .exe program. That will install the Microstation on your computer. Then there's a PDF file there that has the license file on it, and there's also that same license number is in your first class folder. So either place you can get it, and you just need to pop that number onto the software. If you have problems with it, bring it into the classroom. We can try to get it set up. I do recommend that you bring your laptop into class, use that instead of the PCs in the classroom, and that way your homework is all secure and you can take it back and forth with you, as opposed to downloading and uploading from one machine to another. The first chapter of this textbook talks about input devices. Number 1 being the keyboard, using function keys, keyboard accelerators, and the mouse. Microstation is a little bit different than the Autocad program in that it is more mouse oriented, less keyboard oriented. There are button functions. You can see there's design files and seed files, and that's another thing that we're going to emphasize, and the reason we talk about files right in the first classroom session is because we want to make sure that you have a set library that we can put our files. Everybody's working into the same library structure, folder structure on the computer, so that if something gets lost, we can easily find it. We don't want to just dump stuff on the desktop. Opening and referencing DWG files, it can be done. DWG is the native file of Autocad. We can open and close those, work with them directly in Microstation, so there's no difference there. We're going to talk about referencing. If you're familiar with Autocad, they have a term called X-refing, or X-referencing, being able to bring another drawing into this drawing reading it in without actually having to redraw it or copy it into the folder. And then talking about file menus, menu directories, and the view windows. New concepts and commands in this software. We have some scroll bars and menu bars that are a little bit different. We'll talk about those a little bit more as we look further into this chapter and see some of the graphics so that I can point out some of those specific areas that you're going to see in the software. The keyboard, standard keyboard, and it says all keyboard inputs require an enter key input which instructs the computer to read and execute the keyed in construction. Now, we're not going to do a lot of key in construction. We're going to do a lot of shortcut keys, so you should know about this, but as opposed to Autocad, we're again a little bit more mouse oriented. Some function keys in Microstation that we're going to look at that are standard. F1 is the help key, your F1 function key. F3 is backup. It may not work with the PCs in the classroom, but it will certainly work with your laptop or your own PC. F5 is choose element, F6 place a fence, and F9 is update. These can all be customized to however you like them. If you have a particular command that you like to use a lot and you'd like to attach it to a function key on your own machine, you can create that function and do whatever you really want to do with it. And there also you can use the control function key, the alt function key, and the shift function key to increase the number of function keys available within your workspace. Again, we don't use these that much. I tend to get more into shortcut keys as opposed to function keys, but it's good to know that they're there. Keyboard accelerators or keyboard shortcuts. Standard Microsoft shortcuts, Control X cuts to a clipboard, Control C copies to a clipboard anything that might be selected, Control V will paste from the clipboard, clipboard being the memory within Microsoft software or the Windows software that holds that information until you're ready to paste it back in. Control S is save, Control O is open, and Control P is print. Mouse cursor controls. We use actually a 2-button mouse with a wheel, or it could be a 3-button mouse. Most mice you're buying now are 2 buttons with a middle wheel. That middle wheel can also be used as a middle mouse button if you push it straight down. You see the letters D, T, and R. D is for data, T is for tentative, and R is for reset. Your data button, your left mouse button, is to set a point. Basically sets a point command. Tentative is the ability to set a tentative point, but you're not actually putting the point there. Sometimes we use that when we just want a place marker. And as we get into the next session, the next class, we're going to utilize that to do some things called offsets and whatnot. So don't worry about it too much. And you can also use the wheel by default as a zoom in, zoom out command. The right is a reset, meaning when you're done using that particular tool, you hit the right mouse button and it stops and you let you go grab another tool. So if you're drawing line strings, you're continuing to put points on the screen until you hit that right mouse button to stop it. So you can do multiple points for the line screen. Again, down here it shows you how to adjust those button assignments. Within this screen, if you do want to change a button assignment, normally it'll say data, left button, tentative, middle button, reset, right button. If you want to change this, it might say tentative, left, right mouse button chord. In other words, you push both buttons at the same time to do a tentative. What you do is you move your mouse down into this button definition area with this highlighted and hit your middle mouse button. This will change. So it's easy to customize. And they explain this left mouse button, center mouse, or tentative, and the reset button down here at the bottom. Design files, seed files, and prototype files. We're going to use primarily design files and seed files. A design file is a native drawing file that is created in the CAD program. A seed file is a template. In other words, it's the same as the design file, but some people have seed files set up that have all preset information, might be dimensions, working units, screen size, tools. All of those things can be all preset into a seed file, so when you bring it up you don't have to reset it. It might come up, another drawing might come up in meters, and you have to change it to feet and inches. In this case you can have a seed file that's already set to feet and inches. When you bring it up, everything is set the way you like it. So and that's basically the same as a prototype file, where you're creating a drawing that has some preset information. You can have a prototype or a seed file that might be one for architectural, a seed file for mechanical, a seed file for civil, maybe an architectural file that might be 1/4 inch scale, an architectural file that's 1/8 inch scale. Text sizes, dimension styles can all be set up in seed files so that they only have to be set up once, and that's kind of the standard that we're going to use here this semester for the same type of application. And opening reference files from Autocad is basically as simple as just looking for a DWG file and clicking on it. There's an exercise here where you can log into the computer using an access code if it's needed, but in this case you don't need it. You can change your password. That we really don't care about that. Microstation will take about 20 seconds to load up. It does have a lot of information on it. You need to be on the internet for it to check your license. If you're not on the internet and you've still logged in previously with a license, it allows you to have 29 days before it requires that you rehook to the internet. So there's no excuse for I couldn't get my homework done because I couldn't hook into the internet, because it still will let you use the software. Dialog buttons and settings, basically just the ability to bring things up. There shows you the different type of dialog boxes, check boxes. One of the things that we emphasize here is when you bring a tool up in Microstation, you don't need to drag it off or close it. When you grab your next tool, it overwrites the previous one. So we try to eliminate as much motion with repeating or having to redo things as possible. I use the example of trying to think about this type of software and CAD drawing or technical drawing the same as playing a musical instrument. If you're playing a guitar, you have one hand on the strumming the strings and the other hand is laying out the chords. And when we're doing CAD work, we have our left hand on the keyboard and our right hand on the mouse, and we keep them there. It's not typing class. We're not keeping both hands on the home row and then going to the mouse. Try to work with one hand on the keyboard, one hand on the mouse, and with this particular software it should increase your speed substantially in how fast you can get things done. The created design file just shows us here how we can open one up. You'll see a seed file at the bottom. This is kind of hard to see, but when you do start working with it, you'll see these seed files. You can select the one you want, or you can create your own. This is also be as simple as bringing up a previous drawing that you've done in the past and just doing a save as and calling it something different to make a copy of that particular drawing. So it's not rocket science. This is the screen we'll see. Normally we'll use a black background. We don't necessarily want to use grid patterns on our screen, so I usually have those taken off, and we'll show you how to do that when we start our first drawing. Really not too much there. There's a main menu over here. It's a little bit different now with the V8i. There's more information on this side. We have some view windows. You can see this drawing here shows us the different tools that are available in their names. It has a main toolbar. We have some view controls down here at the bottom that allow us to zoom in, zoom out. Fit view is right in the middle. I call it the mountain range. You can dock these tools. One thing to remember when you're looking at these tools, you look at this one, it's our SmartLine tool right here. You see it has a little arrow right there in the corner. That arrow is actually a flyout. So if you hold your left mouse button down on that tool, it's going to fly out with more tools underneath it. So this is just the first tool in a group of tools. Same with all the shapes. Whenever you see that little black arrow on any tool and you hold your left mouse button down on that, it's going to fly out and show you more information. Opening and closing windows. Really you don't need to You can close out some, but a lot of these just overwrite themselves so it doesn't clutter your screen. And they've done that purposely so when we're working in a small area we don't need to continually go and clean off our screen of toolbars, because these will overwrite each other as we open them up. Shows us some different types of using save as to create a new file. What we're going to do is, if you're using the PC in the classroom, there's a student temp E drive. You can create a directory on there called CET120 with your initials at the end. In a create a folder there. In that folder, as 3 subfolders you're going to put in there. One is going to be called projects, one is going to be called utilities, and the other one is going to be called seed files. Once we create that, that's where we're going to keep all our homework. And if you're working off a laptop, you want to just do it in like My Documents, create a CET120 folder, and put the same subfolders underneath that: projects, utilities, and seeds. Exiting Microstation is pretty much same for anything. You just file exit or just close it out. Microstation does save on the fly, so it's not a big deal. When you close it out, it automatically saves your drawing. The Microstation Manager is basically your file manager. You can still use this to create new folders from within Microstation, so it's not necessarily that you use My Computer or the Windows Explorer. You can open previous files. If you open up Microstation, look at File Open, you'll see the last 4 or 5 previous files that you had open. You can copy, rename, delete, merge, and find out file information right from this screen. You can compress a file. What the compression does is it basically takes out of memory anything that you might not have done. So it basically eliminates your ability to undo. Anything that it's holding in the background, it will take out of its memory and just compress the drawing down. Down here is your main menu toolbar. I can get down through this. It's a little different now, but here's your element selection tool, is this big arrow. Fence tool. There's some, I think that's a cell tool. Our line tool. This is a hatching tool. Shape tool. Some arcs and curves. Circles and arcs. Text tool. Manipulate elements. Cell manager. Measurement tool. Dimensions. Selection. Change element. Modification or manipulation tool down here, and then a modification tool here. This is actually red X, which is your delete tool. These have moved around a little bit. Shows some of the flyout tools that you see from that main toolbar. In other words, you see your smart line tool up here, but it also has a regular line, a multi-line, a sketching tool, Bezier curves, sketching perpendicular, but 90% of the time we're going to use that smart line tool. And the same with this. You can open up more tools that may not be on the screen. You can resize them. You can place them anywhere you want on the screen, but a lot of these will just go out while you're doing the operation and then disappear when you're done. Docking and floating toolbars. A lot of these can be just pulled over and docked to the side, or rather than being out into your drawing screen. So we're going to do some management of making sure that we learn to draw with a minimal amount of menus and tools up on the screen. Keyboard input. There is under the workspace a key in window that allows you to key in commands, similar to what you do in Autocad. This can be docked down at the bottom, so it's just a single line. And there's some other exercises here in the workbook, and it talks about docking and resizing the key in window here, so you can actually put it down in the bottom of your screen so it emulates an AutoCAD type function. Again, key ins are a little bit slower, so we're going to try to work with keystroke commands, AccuDraw, shortcut key ins, and that type of thing as we get into the software to make it easier to work with. More input device information here. There's a pop set tool. If it's green, we don't really use that too much. We can play around with it. You can show and hide toolboxes. Any toolbox, if you just right click on it, it allows you to make other tools disappear or add more tools that may not be turned on at that time. So we'll probably run into that as we move through the semester. There's some notes here that you can read through. talking about some of the similarities between CAD and using it on the drawing board. We're not really getting away from some of the basic rules of drawing and board drafting with by hand, but we're going to emulate those in a computerized CAD setting, and hopefully you'll find it much easier as the more we move along through the semester. And that's the end of the chapter. Really what I'm going to ask the students to do is spend some time trying to get the get the software installed. The next class, which I'll be recording with some of the highlights similar to this, will introduce us and get started on our first drawing. It's going to be based on exercise 20 in the drafting workbook, and we'll pull that up and take a look at it at the next session. So that's basically what we're going to go over. Read through chapter 1, get ready to start drawing at the next class, which is held on Wednesday. So at this point, I guess probably I've hit most of the highlights from this class, and we'll get some more of these put together later for your use. Okay, thank you.